Video 17 deals with station and skew angle computation. A skew angle is illustrated here as the angle of the pipe to the main road. And here we're looking at a skew angle of less than 90 degrees. And let's illustrate how you can compute this. Now if we go to P3D, here we're starting from scratch, so you witness loading of a P3D file. We're going to open a scene. A scene is stored as a P3D file. It has that extension, the .p3d, and we're going to load the last one here. And this is the file that actually has an existing pipe in the form of a little storm sewer with a beehive inlet drain going out to a head wall on the other side that has been pushed into the hill. And we want to go about computing what the skew angle is with reference to this road that we'll call US 68. Now, here we have the ability within P3D to import a Carlson centerline file as made in Carlson Survey or Carlson Civil, and we have one, and it's US 68, and we're going to choose that and open it up, and it gets into our list. Now when we expand the storm sewer and go to the pipe and pull down here, we'll see that right now it's not showing any skew angle because we have no reference center line or polyline selected. We can go into this option and we find US 68 because we just imported it. So now it displays our 81.593 in decimal form in this case as configured skew angle. Now if we go back to the CAD, you see we've drawn that 81 degree skew angle in the CAD as shown there. But you can also design in a skew angle that you want. So let's go ahead on this site and drain it across and control the skew angle of this particular pipe. Now let's size the pipe correctly, and that's done by selecting the rainfall event. We're in rational Q equals CIA peak flow calculation right now, and we will calculate the storm. Oh, we have to unlock it because we just loaded a P3D file. It's very typical. Unlock it. It advises the user that someone has been in here before and created a storm that they may want to retain. Now we're going to run and briefly pause. We resume. It has found our accumulated water, and we will now put in a culvert from that low point. We'll spin it around, be sure we get the correct low point, and take it across the road right in that crease of land there, and we're at a positive slope. We better go downhill more. And how about a 1.28% slope? That looks good to me. Maybe we'll lock it in at negative 1.25. And now let's examine what the skew angle is here. Well, let's select our US 68, and we have a skew angle of 11. Now, some DOTs, and Kentucky Transportation Cabinet is one of them, prefer a skew angle that is divisible by 15. So how about a 15 degree skew angle? Do you see how it shifted? And now look at its station. Its crossing station is 2096.5. That's an odd station. So put it over to 2100, and if we get in close, you'll see it shift down the road just a little bit. 21, let's click in here, 2100. Watch it shift. There. So we have the correct skew angle and an acceptable skew angle and a nice even station. And then at this point, is when it's a good time to drop the head wall on it. And let's try an Oldcastle, one of our favorites. Place it on top of the pipe. See, that's completed and finished. And then at this point, on this pipe, which is, by the way, this culvert pipe 4, or culvert pipe 1 in this case, is a dimension of 18, very nice, and fits nicely on the Oldcastle standard head wall that we use. And now we can push this into the hill after it has been moved to the right skew angle and the right station. This is a good time to reduce its length by pushing it into the hill to a 5-inch freeboard. That'll cut off a little bit of the pipe there, and our 133.8 is going to be reduced to 129. Now we're under 130, and we'll do the same thing at the inlet, and we will pick the inlet and push that into the hill in the same way. It won't reduce as much. That might make it to 125 approximately. 126.685, and there you have it. We've actually controlled the skew angle, we've controlled the slope, we've controlled the station, and we've also calculated the station and skew angle of an existing pipe.